Hello guys, welcome back. Today we are going to understand another question on the DP on string, right? So we have already uploaded 3 questions on DP on string, right? And you can see by going to watch all those videos, right? And it is very important to see all the DP on string questions, right? Because you will have the basic understanding as well as you are able to do medium level questions, right, on DP on string. And it is most asked questions on the, you can say, interview, right? So the first question I have already uploaded is the longest palindromic substring. Another I have already uploaded the word break, and the third that recently I have uploaded is the longest palindromic subsequence, right? And this time I'm going to start in the fourth video of DP on string is edit distance, right? So please go and watch in the playlist, right, edit distance as well as longest palindromic substring, word break, longest palindromic subsequences, right? We will watch, right? So let's see this question 72. So the Leetcode 72 questions is based on the DP on string, right? So edit distance is saying we have given two string word 1 and word 2. We have to return the minimum number of operations that is required to convert word 1 to word 2. And you have the following operations that is permitted on the word, right? You can insert, delete and replace the characters, right? So the first character we have given, first word we have given is word 1, and that is horse, and another word we have given is a rose, right? So from the word 1 to word 2 you can perform all these operations, and you have to make from word 1 to word 2, right? To do that, you can see in the explanation that if we have horse, right, and we are going to replace h with r, right? So this will become rose, right? Now we have to remove r, it will become rose, right? Then you have to remove e and it will become rose, ros, okay? And it is equal to that. So I think you got the answer, you have understood the question, right? So we are going to see the answer, how we are going to do that. So if you see the edit distance, right, question, right, you have understood the example, then what you will understand that edit distance is a term, right, that is used in the computer science, right? So by the definition of edit distance is a string matrix, right, a way of identifying how similar two strings, that is words, are you can say to one another, right? That is measured by counting the minimum number of operations which is required to transform one string into another one, right? So if both are different type, right, in the w1 and w2 are different, right? So each having different types of the operations, right, to transform one string to another, right? And that you may have aware of the one Levi C10 something name saying the distance, right? So this distance, like if you have seen the some application, right, you are writing some text word, right, and that text words like I'm writing apple, right, apple, so it is correct. But if I write APLE, apple, so it will give you the hint to make it apple, right? Like in the Microsoft Word, right, you are giving the giving your hints, right, to make it correct, to make the correct word, right? So that is the real world application, right? So Levenshtein distance is also a way in which you can perform the transformations, like operations like addition, delete and replacement you can do, and you can make, right? Let's suppose another one. If we have in the word 1 is face, and we have to make it Wednesday, right, like this. So what you will observe, the starting two characters are same, right, that we are not doing anything. But here we need one character, that is D, so we will perform operation add. The next three character is same, that is no problem. But the next character we have F, and that should be D, so we will replace here. And two characters we have given AY, and AY is here, so here is missing, no need required of this S, so we will delete this element, right? So this is the way you can do the performation, right? So as you can see, what also make it more interesting to solve this problem is that we have many real world application on these questions, right? So think of it like if you want to find similar score between two string, right? So the lower the edit distance, the more similar they are, right? So one of the real world application of this algorithm is to autocorrect feature that is used in the text editor. You have seen many times, right? So when you have make a spelling mistakes, right, the text editor, like a few advanced one like Microsoft Word, you can say, highlights the nearest matching word to the type word, right? It will say the list of word with the list distance, right, from the dictionary, that is pop up for as a suggestion, right? So in this approach, what we will do, we are going to see the recursive way, right? And it is very easy way, right? So let's suppose this is your DFS utility method, right? We are passing word 1 and word 2, right, in which we will pass the length to length, right, word 1 and word 2. So as you can see, this recursive call will get called through this method. So we have word 1, word 2, we have word index 1 and word index 2 we are passing, means last position we are passing, right, because the word length we have, right? So what we will do, first of all, if length of the word length first is 0, we will return word length 2. If first word length of 2 is 0, means we will return word of 2. Why we are doing this? Because if suppose any of the string is, there is two combination, like here and we don't have here, right? If we don't have here and we have ABC, like this, okay? So any of the distance is coming null, right? We will return the particular element as a response, right? The one index, you can say. Now we will check if both characters are same, right? The word add character, the last character of this one and last character of this one, right? This index, if both are same, means what we will do, we'll check the another two, right? Means let's suppose we have A, B, C, okay, and here we have A, C, C, like this, okay? So this character, right, and this character, okay? So we will start from here, right? This character, we will check with this character. If both are same, right, what we will do, we will come to here, right? We will come here and will come here, okay? So the new string is this one and this one. This is your W1 and this is your W2, right? So we will check like this, right? So we are decreasing I minus 1 and J minus 1, right? So you can see I minus 1, J minus 1 is happening. Word index 1 minus 1 and word index 2 minus 1. So this recursive function will call again, and this will go on, right, till the object is matching. Let's suppose this is B, right? So this is also match, this is also match, okay? And if this is E, so we will come to here. So now the string is like this only, okay? We'll check that one. So what we'll have to do, if the character is not matching, let's suppose this time character is not matching, so now you can perform insert, delete and replace operations, right? So first of all, we'll check the word. So this will the correct index, and we'll check this index word to index minus 1 we'll check, and here in the delete operation from word to index minus 1 we'll check to word to index 1, right? And index minus 1, index minus 2 will do, minus 1 will do, and we'll check the replace operations. So when the replace operation will work with the same index we have to do, right? When the delete operation will do, so we will reduce the I index will reduce, right? And when we do insert index we will do, then what we will do, we'll decrease J index, okay? And these are the operation will happen, right? So three character we have A, B and C, right? Three things we have A, B, C as an integer, right? So we will check which is minimum. So first we'll check with B and C. So this is your B and this is your C. Which one is minimum? That will go to check with A, right? And which one, let's suppose A, B, C, which is list one, like A is the list one or B is list one or C is list one, that will come, and then we'll do plus 1, right? So each time this recursive call will work like this, right? So this time what will happen? So see, the first time what we are trying to do, give me 1 second, let me remove this one. So first of all, what we are doing here, we will check the indexes, right? If it is any of like word 1 index or word 2 index are 0, right, we will return the index of another one, okay? Means if two strings are same, right, then what we will do, we will check this one, right? How we'll check? If both indexes are same, means word 1 and word 2 both are same, we are not going to perform any operations, right? So in the last you will return here as a 0. We are not doing anything, right? But if any operations we are going to perform, you can see here we are not adding anything here, right? Means if the two strings are same, right? So the edit distance is what? 0. We are not performing any operations, right? So word 1 and word 2 both are same. Okay, like say if word 1 we have ABC, word 2 we have ABC, so we do not require any operations to perform, right? Because we have seen I is here, J is here, right? Suppose this is your I and this is your J, right? So each character we are checking, right? I minus 1, J minus 1. Then we will come to B and B. I minus 1, J minus 1. Then we will take A and A, right? Means there is no any other operations are required. So we will return 0 as a answer. Then if both characters are not same, right? Means word 1 and word 2 both are not equal. So the operations we can perform is what? Add, delete or replace, or you can say insert, delete or replace, right? Any of the operations you can perform. If and only if the character at a certain position in the word 1 and word 2 are not equal in the corresponding characters, you can say, right? So you can see here we were saying A, B, C, and this is A, B, C. So index is what? 2, 1 and 0, right? So this is your W1 and this is your W2. If both characters are matching, right, this matched, then we will check this one, and this, then we will check this one, right? So all these characters are matched, means we are not performing any operations. But let's suppose any of these character, let's suppose here is D, right? So we have to replace this D, right, with what? With C, correct? And we will say one operation is required, so we are doing +1. Okay, so any of these operations we will do if it is not matching, and that's why we will perform any in these operations, right? So first of all, how we are going to check, right? So word 1, word 2 we will pass, right? So what we will do, the index will remain same for this one. 2 will check with what? The word 2 index -1. If this is matching with this one, right? If it is matching with this one, then what we'll do? We will insert here some value, but this is not matching, right? We will leave that, right? If we are going to see if the word index this element, right? If this element is not matched with the word index here, right? Means this element is not matched with this one, right? Then we will say delete operations we will perform here, right? So you can delete by here directly or any other position if you want, right? So and similarly we'll check this one. Means in the delete word you have not to delete exactly, we have to reduce the index, that will automatically get deleted. Means number of operation will get +1 added, right? Means what trying to say here, let's suppose we have what? A, B and C, and here we have A, B and D, right? Means we are performing this one, right? Index 1 and I, and this is J, right? Means what we will do, we will reduce this one. For the delete operation you see only we will reducing what? This index. Means we are going to check this index. Now we are not going to check this index, so we will check this index, right? Value we'll do -1 with this index. Okay, means we have reduced this one. Okay, so like that you have to perform the operations. You are performing replace operations, you are using delete operations, that you have to see. If you are replacing the index, means this index we are going to check with this index, means we are replacing this one. But when we are deleting this one, if it is not required, means we have to delete this one. We have to come to here. I think you got it, right? Take your time, pause this video and see. You will understand the way. So now we will see the memorization way, because that code will give you can say a time complexity issue, right? So in this video what we will do, in this part what we will do, we will make a memo. We will store the memo, right? I +1 will length +1 will do. You have made a matrix, right? Like this memo, and you will increase I +1 J +1 time, and only rest of the thing will remain same. What we will have to do, we will check if it is already calculated, we return from that index, right? If not, we'll take a minimum distance, and if both characters are matched, then we will say minimum distance is 0, right? And if not, if it is not matching, means we have to delete, insert, delete or replace, any of the operations we will do, and we'll say we'll do +1 here. Similar way, only we have to take that position will return minimum distance. What is the minimum distance now? And we'll store that minimum distance at the given area, right? And we will return the mean distance, right? I think you understood. If you understood the previous one, this is also easy. Only we have to add memorization. In the memorization, we will take all the matrix, right? And we will initially fill with null, and if we have already calculated, we will put the data there, and we will check. We'll each time if it is matching the character, means minimum will become 0. If not matching, we will adding some character to the mean distance, and that mean distance we are going to minimum distance we are going to add on to the memo, and from the memo we'll return if it is already calculated. If not, we will return the minimum edit distance. Okay, so I think you got me. If you have any doubt, please ping me in the comment box, right? I will definitely help you there. Okay, so that's all for today, and hope this video will help you to understand the concept, right? So let's suppose for the distance, right, if we have m is the length of the first string and n is the length of another string, so m into n will say this is your time complexity and space complexity too, because we are taking this memo of m and n. Okay, if you any doubt in this video, please ping me in the comment box, right? And let's see another part of the another video of this series of DP on string that we will see today.